So let's take a look at implicit differentiation. Now, what we have been doing so far is known as explicit differentiation, where we would derive just the x variable. But in implicit differentiation, now we're going to start to derive both the x and y variables. Now, one of the most important things to keep in mind while doing implicit differentiation is that dy dx, or the derivative of y with respect to x, is going to be equal to y prime. Those two are interchangeable and they're basically the same thing. So the problems that we'll do, or the example problems that we'll do, will ask you to find dy dx or y prime. So for these next set of questions, let's go ahead and find dy dx or y prime once again by implicit differentiation. So for number 1, we have x squared plus y squared equals 1. Now the very first step in doing implicit differentiation is if I go ahead and move x squared plus y squared equals 1 a little bit to the right, we have to derive first both sides of the equation. So I'll just go ahead and put it in parentheses and say d over dx, because we're going to derive everything with respect to x. That's the very first step. So starting off with the left side of the equation, the derivative of x squared is just going to be 2x. But now we have plus the derivative of y squared. Well, keep in mind, when we do implicit differentiation, every time we derive y with respect to x, since those are two different variables, we have to always multiply by dy dx, or once again, dy dx and y prime are the same thing, so we can multiply by either dy dx or y prime. Since y prime is easier to write, I just go ahead and multiply by y prime all the time. So we have x squared, derivative of x squared is 2x, plus the derivative of y squared, that's going to be 2y. And because we derived y, we multiply by y prime, or dy dx. And that equals derivative of the right side of the equation. Well, that's just a constant, so derivative of 1 is going to be 0. So now we need to go ahead and find dy dx or y prime. So all we have to do is isolate y prime. So if I go ahead, 2y prime equals, I'll subtract over the 2x, so we get negative 2x. Then I can divide the 2y, so y prime equals negative 2x over 2y. Realize that 2's will cancel, and the final answer, y prime or dy dx, is equal to negative x over y. So now for number 2, we have x cubed plus x squared y plus 4y squared equals 6. Same exact process here. First step is always to derive both sides with respect to x. So derivative of x cubed is going to be 3x squared. Now for the derivative of x squared y, we do have two variables being multiplied by each other, so we have to use the product rule. So we do have a plus here, and then we can take the derivative of x squared y by using the product rule. So we're going to take the derivative of the first function, derivative of x squared is 2x, times the second function unchanged, so times y, plus the derivative of the second function, y. So we have the derivative of the second function, which is y prime, times the first function unchanged, so times x squared. And then we have plus the derivative of 4y squared. Derivative of 4y squared is 8y to the first, or just 8y. And because we derived y, we have to multiply once again by y prime. And that's going to equal the derivative of 6, which is just going to be 0 because that's a constant. So now, in order to find dy dx, I need to isolate the y primes. So if I go ahead and subtract over 3x squared and 2xy, we get x squared y prime. I'm just going to go ahead and rearrange those terms. And then plus 8y prime equals, now when I subtract those two over to the other side, we get negative 3x squared minus 2xy. So now in order to isolate y prime, I'm going to factor out a y prime. So we get y prime times x squared plus 8y equals negative 3x squared minus 2xy, and then I can go ahead and divide over x squared plus 8y. So the final answer for y prime or dy dx is going to be equal to negative 3x squared minus 2xy over x squared plus 8y. Now for number 3, we have e raised to the power of x squared y equals x plus y. Once again, first step, always for implicit differentiation, we derive both sides with respect to x. So now, we have e raised to some function here, or some inside function x squared y. And remember that the derivative of e raised to some power u, or some inner function u, we have to use a chain rule, is going to be e to the u times the derivative of the inside function, so times u prime. So if we go ahead and apply that formula, the derivative of e to the x squared y is going to be e to the x squared y times the derivative of that inside function, so derivative of x squared y. Because we do have two variables being multiplied by each other, we have to use the product rule. So using the product rule, when we derive this, we take the derivative of the first function, which is 2x, times the second function unchanged, so times y, plus the derivative of the second function, derivative of y is just y prime, times the first function unchanged, so x squared. And then we have equals the derivative of x plus y. So the derivative of x is just 1, and the derivative of y is going to be y prime, so we have 1 plus y prime. Now we need to find dy dx or y prime, so before I do that I need to go ahead and distribute e to the x squared y into the parentheses. So we'll get 2xy times e to the x squared y, and then plus, I'm going to go ahead and rearrange those two terms. So we get x squared y prime times e to the x squared y, and that's going to equal 1 plus y prime. Once again, we need to find y prime, so I'm going to go ahead and put all the terms that include y prime onto one side. So in order to do that, I'm going to go ahead and isolate y prime by subtracting 1 to the left side and subtracting this term to the right side. So we get 2xy e to the x squared y minus 1. We went ahead and subtracted the 1 over to the left side, and then that's going to equal y prime. I'm going to subtract this term. Once again, I'm doing this because I'm trying to get y primes all on one side of the equation, so I can isolate minus x squared y prime e to the x squared y. So now what I need to do is go ahead and factor out y prime from the right side of the equation. So I'm just going to go ahead and rewrite the left side. 2xy e to the x squared y minus 1 equals y prime times 1 minus x squared e to the x squared y. So now I can go ahead to isolate y prime, divide this term, or divide that parentheses over to the other side. So for the final answer, we get 2xy e to the x squared y minus 1 over 1 minus x squared e to the x squared y. That's going to equal y prime, or dy dx. Now for number 4, we have x times y equals cotangent of x times y. Once again, I'm going to derive both sides with respect to x. So derivative of x times y, because we do have two variables being multiplied, we have to use the product rule. So in order to use the product rule, we're going to derive the first function, derivative of x is just 1, times the second function unchanged, so times y, plus the derivative of the second function, derivative of y is just y prime, times the first function unchanged, so just times x. That's going to equal the derivative of cotangent of xy. So derivative of cotangent of some inside function u is going to be equal to, now remember the derivative of cotangent of x is negative cosecant squared of x, but we have this time instead of x we have u, so negative cosecant squared of u, and we have to use the chain rule in this case because there's an inside function u, so we have to multiply by u prime, or the derivative of the inside function. So using the formula, derivative of cotangent of xy is going to be negative cosecant squared of xy times the derivative of the inside function, once again because we're using the chain rule. So derivative of x times y, well, we've already found derivative of x times y on the left side of the equation, which ended up being this, so we can go ahead and copy that over to the right side of the equation. So multiplied by the derivative of x times y, which is 1 times y plus y prime x. So now we can go ahead and simplify. So 1 times y is y, and so then y plus, I'll rearrange the terms, so we get y plus x times y prime equals negative cosecant squared of xy times 1 times y is y plus xy prime. Now before I find dy dx or isolate y prime, I'm going to go ahead and distribute the cosecant squared inside the parentheses. So rewriting the left side of the equation, y plus xy prime equals, now we distribute the negative cosecant squared, so we get negative y times cosecant squared of xy, and then minus xy prime times cosecant squared of xy. So in order to isolate y prime, I'm going to subtract the y over to the right side, and then add over the xy prime cosecant squared to the left side. So we'll get xy prime, I'm going to add this over, so plus xy prime times cosecant squared of xy. And then on the right side of the equation, we have a negative y times cosecant squared of x times y. And then I can subtract over the y, so minus y. So now I can go ahead and factor out the y prime from the left side of the equation. So we get y prime times x plus x times cosecant squared of xy. And that's going to equal, once again, negative y cosecant squared of xy minus y. So then I can go ahead and divide over this entire thing. So we have y prime equals negative y cosecant squared of x times y minus y all over x plus x cosecant squared of x times y. Now I can actually simplify this even further because I'm going to go ahead and first factor out a negative y from the numerator. So we'll get negative y times, we have cosecant squared of x times y, and then plus 1, over, and then I'm going to go ahead and factor out an x from the denominator. So we get x times 1 plus cosecant squared of x times y. Now realize that 1 plus cosecant squared and cosecant squared plus 1 are the exact same thing. They will cancel, and so we're left with y prime equals negative y over x. And that's the final answer. So now for the rest of the video, let's take a look at the derivative formulas for all 6 inverse trig functions. And the good thing about these are you only need to memorize 3 of them because the other 3 are just going to be the negative versions. And so the first one we'll start with is the derivative of inverse sine or arc sine of some function or inner function u. Well, the formula for that is going to be u prime over the square root of 1 minus u squared. So then the derivative of inverse cosine of some inside function u is going to be equal to negative u prime over square root of 1 minus u squared. So inverse cosine is just going to be the negative version of inverse sine. Now let's say we have the derivative of tangent or inverse tangent of u. The formula for that is going to be u prime over 1 plus u squared. So then the derivative of inverse cotangent of u is going to be equal to negative u prime over 1 plus u squared. And finally, the last two, we have the derivative of secant of u, or inverse secant of u, which is going to be u prime over absolute value of u times the square root of u squared minus 1. And then that means the derivative of inverse cosecant of u is going to be equal to negative u prime over absolute value of u times the square root of u squared minus 1. Now keep in mind the inside function u can be anything. It could be x, it could be 4x to the 7th plus 3, but whatever it is, you can use these general formulas to evaluate the derivative. So for these next set of problems, let's go ahead and find the derivative. So for number 1, we have y equals inverse tangent of the square root of x. Now once again, the derivative formula for arctangent or inverse tangent of some function u is going to be equal to u prime over 1 plus u squared. So in this case, if our u is the square root of x, let's go ahead and use the formula. So the first thing we have to do is find u prime, or the derivative of the square root of x. So we can rewrite square root of x as x to the 1/2. Now if we were to find the derivative, we can just use the power rule, where you bring the power down, and then subtract the power by 1. So 1/2 minus 1 is negative 1/2. So we can simplify that to 1 over 2 times the square root of x. So u prime is going to be 1 over 2 times the square root of x over 1 plus u squared. So 1 plus, once again, if u is square root of x, square root of x squared will just be x. So then I can go ahead and bring 2 times the square root of x to the denominator. So we'll then get y prime equals 1 over 2 times the square root of x times 1 plus x. Now if you want to distribute 2 times the square root of x, you can, but this is an acceptable answer. So now for number 2, we have y equals inverse sine of 2x plus 1. So once again, the derivative of inverse sine of some function u is going to be equal to u prime over the square root of 1 minus u squared. So since u in this case is 2x plus 1, let's go ahead and use the formula. So up top we have u prime, so y prime equals the derivative of 2x plus 1 is just going to be 2 over the square root of 1 minus u squared, so 2x plus 1 squared. Now I can actually go ahead and simplify what's inside of the radical on the denominator. So we get 2 over the square root of 1 minus, I'm going to go ahead and FOIL 2x plus 1. So then we'll get 4x squared plus 4x, and then we have plus 1. Now I can go ahead and distribute the negative into the parentheses. So we get 2 over the square root of 1 minus 4x squared. We have minus 4x, and then minus 1. The 1 and the negative 1 will cancel. And so we're left with 2 over the square root of negative 4x squared minus 4x. Now what I can do here is go ahead and factor out a 4. So then we'll get 2 over the square root of 4 times negative x squared minus x. Now the square root of 4 is 2, so I can take that outside of the radical, and the 2's will cancel. So what we're left with for the final answer is y prime equals 1 over the square root of negative x squared minus x. Now for number 3, we have y equals inverse cosine of e to the 2x. So the derivative formula, once again for inverse cosine of some function u, is going to be equal to negative u prime over the square root of 1 minus u squared. Now in this case our u, or our inside function, is e to the 2x, so let's go ahead and use the formula. So the formula is going to be negative u prime, so we're going to go ahead and take the derivative of e to the 2x. Now remember, the derivative of e raised to some function u is going to be equal to e to the u times u prime, just like the chain rule, because we have to have e to the u and then multiply by the derivative of the inside function as well. So in this case, derivative of e to the 2x is going to be e to the 2x times the derivative of the inside function, so derivative of 2x is just going to be 2. So now over, we have the square root of 1 minus u squared, so square root of 1 minus e to the 2x squared. Now if I go ahead and simplify this, we get negative 2e to the 2x over the square root of 1 minus, now e to the 2x squared, because we have a power to a power, I can multiply those two. So we have e to the 2x times 2, or e to the 4x. And that is going to be the final answer for y prime, or the derivative.